Okay, here's a quick lecture to kind of get us started for this week. As far as the textbook goes, I want to skip ahead. Chapter 4 deals with programming devices, and for the most part, with few exceptions, that's going to be a PC, and we're gonna work on that. Uh, Chapter 5 deals with memory organization, and there's some useful information in there, but I think we can summarize it later on. I would like you to, in the next week, look at Chapter 6, which is numbering systems. Last semester, a lot of students complained about this, saying it was, unless they already had experience dealing with different numbering systems, they said it was very challenging. So I'd like you to read through and try to do the questions, and then we'll take a look at the details in class next week. But what I want to do this week is introduce the actual devices that we're going to be programming and start to understand the symbolic language that we use to make a program. This information in these slides comes from the Alan Bradley user's manual for the Micrologix 1000. And in SAIL, that's in the Lessons tab for the PLC course under Web Resources. Micrologix 1000 manual. It's a very large PDF file. In fact, if you on your home computers, if you like, you can do a right click and then save target as and save it onto your computer to make opening it up in the future a little bit faster. And this goes into great detail on all the instructions, and so I extracted some different parts to talk about and put them in these slides. This gives an overview of a specific device, the Micrologix 1000. In this device, everything's integrated, the inputs, the outputs, power supply, processor, memory, everything is in a single block in one unit. This is the device that we connected the power cables to over in the wiring lab, and I think I hooked up one input as well. So here you have an example of various inputs. We're just looking at switches here. They could be sensors. The programming device is going to be the PC. And then the output devices, this one is a lamp. This one is the coil for a relay, just like the one you guys wired up last week. And this is the symbol for a solenoid coil. This represents the scan cycle. This goes into a little bit more detail about it. First step, it reads the inputs. And this little backwards U here, if you recall from, I don't know if you've discussed this in electronics, but that represents microseconds, or 10 to the minus 6th, or a millionth of a second. In other words, it happens really quickly. And then so the first thing it does is it looks at the inputs. Then it scans the program. And then it scans the outputs and writes the output. It determines what condition the outputs should be in, and it writes the data to the outputs. And then there's a communication cycle, or part of where it has to talk to the HHP would be a handheld programmer or a personal computer. So if it's communicating with another device in the process, if another device is connected, it takes a certain period of time for that. And then the overhead, or the housekeeping, That's where it has to update any internal timers and registers and things like that. And then it does that over and over and over again. Program files. This describes the, and this is again for the Allen Bradley device, the system program, and file 1 we don't really care about. The main program is file 2. Any fault information is going to be in file 3. These will make more sense once we actually start using the Allen Bradley software. This week in class, we're going to try to use an online simulator to do some of these things. So you've got program files where the program information is stored, and then you have data files where information about the condition of the inputs, the outputs, timer information, counter information, and so forth are all stored in these files. This is a little bit about the download. When you write a program on the PC, after you finish the program or after you get to a point where you want to put it into the PLC, you download it. You download it from your PC to the processor. And on the other hand, or on the flip side, you do an upload. You take what's in the processor and you upload it into the PC. While the CPU or while the PLC is operating, you can see what's happening on the PC, and we'll see some examples of that once we start the programming. And then when the processor is powered down, the information in the RAM is put into the programmable memory so that it's retained, so that you don't lose it. And power up is just the opposite. Any data that was written into the EEPROM is put back into the, if you want to think of it as the workspace, the RAM. And then this describes the file numbers for each of the types of files. This is a little bit about how to construct an address, and we're going to do some of that in class, so this might make some more sense to you after that. And that's a little extract from this user's manual. There's a great deal of information in here. It's probably not practical to print it out. There's a lot of stuff that you might want to refer back to, but not necessarily things that you need to memorize or have a printed copy for. But I do suggest you go through and take a look at some of the information. Chapter 4 is where I got most of this information from. If you go through and read that, it might make some of it a little bit clearer to you. So that's how a specific device, that's how the Allen Bradley MicroLogix 1000 works. So what I plan on doing today is to use a simulator to develop our understanding of the concept of how a PLC works. And the simulator is located on plcs.net. It's a free site supported by advertising, so you'll be subjected to 1 or 2 pop-up ads. You just close it when it comes up. And the first, when you go to plcs.net, you should see this, try our online simulator free. So we click here now to try it. And it requires a username and password. All you have to do to create an account is pick a username and a password. It doesn't have to be anything real complicated. And then put in an email, and it creates an account immediately, and you'll be able to log in. So I created an account yesterday. Click my password. I guess not. Okay, I'm in. So once you get in, you have this screen. And this is a ladder diagram. This would be the left rung. This is the left, this would be like L1, L2. And then this is the first rung here. And this has some really good help screens. And well, we'll be working some more with this in class, and I'll be glad to answer any questions that you have. But I will just show you that if you go to Help, click on Help Topics, it has some really good animated help things that come up. So you can see it plays kind of like a video. It'll walk you through the process of creating a simple diagram. So first it's going to put some normally open contacts out there. And then you have to give this would be for associated with an input. So the input has to be given an address, so it's I/0. And then the output is put over here, and the address for that is O/1. And the inputs are the blue buttons on top. The outputs are the red buttons on the bottom. So in this case, when you energize input 0, think of it as closing a switch, making it true, it energizes output 1. And it's just that simple. So we'll be using that in class. There are a couple of little quirks with this that you have to get used to use it, but it's a good way to kind of get the basics of ladder logic programming down.